Hello friends, this is Rupesh and watching CPNet's video series on C++, and in this video we'll be looking into this bit fields in C++. So this bit field is not dedicated to C++, it has come from C. So as this full series is about C++, I'll be covering these points. So what is the use of bit field in C++ or in C? To understand that, let's take an example here. I will create either class or structure because it works in both of this type, and remember this, it works either on class or in structure only. It doesn't work on anything else. Okay, so in order to understand that, let's create a class. Okay, leave it. Let's create structure and date. Yeah, this is very standard way of explaining this bit field. So date has three components: day, month, and year. So unsigned integer day, unsigned integer month, and unsigned integer year. So our data structure is ready for date. D is for date, M for month, Y for year. Correct? So if you will create this date d dot d is equal to, let's make it 8, and d dot m is equal to 8, and d dot y is equal to, let's keep it 1989. And this birth date is very important for me. So as you have put the values here, you can print these values, no problem. So d dot d, d dot m, d dot y. Okay, so let's put some indentation. Or so if you will print this, let's do that. You will get that 8, 8 and 1989. So this is perfect. If you want to store your date, you can go for this. Okay, and let's print the size of this data type. That is very important. Okay, that's why we use this size of date. And if we'll print this, the size is 12. So you might be knowing why size is 12, because this is integer and it will take 4 bytes. So 4, it is 12. Okay, so everything is pretty cool till now. But wait a minute, just think about it, that you're using 4 byte to store month, but we have month from 1 to 12, and then it will again repeat and it will again repeat. So this m is always going to have the value between 1 to 12, and same goes with this one also, because this is date and date is not going to exceed 31. So 4 byte is very much for this one and this one. Okay, so we don't need 4 and 4 byte. That's why this bit fields come into picture. When there is a scenario that you can restrict your data type size, because you know that you won't be ever using that much size in your data structure. Okay, so in that case you can reduce that. And if we will talk about this year can be anything. Okay, so this integer is perfect for that. But month and date are so limited. So in order to calculate that how much bit is needed for this one and how much bit is needed for this one, we should check that what would be the maximum size of your date and month. So month will not exceed from 1 to 12. Okay, so this is the limit for your month. So in order to store this 12, how many bits you need? So if you will calculate that, I know most of the people would have got it. I'll still explain that. You might be knowing this 0001 and till this 1111. So this is 15, and this is 0, and this is 1, and intermediate values will come here. Okay, so as you can see here, the list is showing that you are having 4 bits enough to store 12, because this 12 will come somewhere here. Okay, and if you will take 3 bit goes only till 7. Okay, so this will be 00001. So this is 0, this is 1, and this will be 7. So at max with 3 bits you can store 7, but with 4 bit you can store till 15, means total 16. And here total 8. So you might be knowing what the formula is. Like formula is 2 to the power 3 because this is 3 bit. Okay, so 2 to the power 3 is equal to 8, and here 2 to the power 4 is equal to 16. And why 2 to the power means? Because your number system have only two digit, either 0 or 1. Okay, so from that, how many possible numbers are there? This is the one. Okay, so this is a different topic. We were talking about the size of m. So we got it that we need only 4 bits in order to store month, and how many bits for date. So if you will increase like 2 to the power 5, this is going to be 32. So in this case, from 0 to 31 means total 32. So we need 31 to be stored. In that case, we need only 5 bits so that we can accommodate the bigger date, and which is 31. Okay, so this is how we calculate it. So we need only 5 bits. So in this case we need 5, and in this case we need 4. So let's see the syntax of writing, how to write the bit fields. So this is your program now. Now concentrate here. We're going to write the bit fields. So if you remember, for this one it was 5, and for this one we got 4. Okay, so this is the way of writing bit field. You're saying that I will be taking 5 bits for date variable, D variable, and 4 bits for M variable. Okay, so if we will run this again, we'll get the size 4 byte less. So let's check that. See, everything is perfect, but size is reduced. Before size was 12, now size has become 8. And why 8? I'll tell you that. So now you understand this, that this is the syntax of using bit fields. We calculated that D will not exceed more than 5 bits and M will not exceed more than 4 bits. So we used it like this. And this is going to use 4 bytes of this integer. Okay? But they will not use full 4 bytes. And now let's talk about why it is having this 8 here if we will compile this. So let's understand that. So if you know what is structural padding and packing, you will be able to understand this very quickly. Otherwise, you'll have to go and see those videos of mine. I'll give the link in the description field, don't worry about that. But I'll try to cover that point here also. So this is how it's going to look like, and 4 bytes, right? So this is 4 byte and this is 4 byte. So this is this one. We have this Y here. But this 5 and 4 bits, as this is 4 byte, it means total 32 bits. In that case, either this first portion of this one is going to be 5 and next of that is going to be 4, or this one is going to be 5 and this one is going to be 4. Why I'm saying or? Because this is totally implementation defined. Okay, so however you have implemented your compiler, you will be defining that I will follow this rule or this rule when I am dealing with this bit fields. Okay, so this is totally implementation defined. And why we are using only 5 and 4 but ended up losing this much of space? So the answer is for memory alignment. So as I said, if you know what is memory alignment, it will be easier for you to understand this. But note down one thing: when your compiler is creating memory for your structure or classes, it will search for the bigger data type in this. So the bigger data type is this one, integer, right? So in that case, it will create whatever the size of this one is for the first block. So let's suppose it is going to create that, then it will create first block of 4 size. So there will be total 0 to 3 blocks of memory. And now it will place from top to bottom. So it will start placing this one first inside this block. I'm repeating this again. It will create this block depending on the size of the bigger data type. So it has created one full block of 4 byte. Okay. And then it will start placing from top to bottom. So it will try to fix this 5 bits and it will place these 5 bits first inside this. As I said, it is totally dependent, but for simplicity I will assume that it will place first, and then 4 bits for this M. Okay, now 5 and 4, total 9 bits are occupied, but rest of the bits will go waste. Okay, so out of 32 you are using only 9 bits. Okay, so the rest of this 23 bits are going waste. And yeah, we were talking about something else. We were talking about, we created this memory block of 4 byte because of this bigger data type, and we started placing from the top, and we placed 5, and we found that okay, we can place 4 there, so we placed 4 there. Then we found that we are supposed to place this y now, and y is of 4 byte, but we don't have that much of bits here. I mean, 4 byte means 32 bits, right? But we are left with 23 bits in this block. So what it will do, it will create another block. And as I said, whenever it is going to create block, it will create 4 byte, because that is the biggest memory size here. I mean, data type size here. Okay, so 4 byte will get created and y will be placed here. Okay, so this is how this will work. So now, as you know how to deal with this bit fields, let's look at few points here that we will be covering in this video. So this is the first point that says that force alignment is possible using unnamed bit field of size 0. So what is this force alignment and unnamed bit field? So generally your bit field look like this. So we have this structure and node. I have given this node 1, and this A has 6 bit and 9, I mean this B will have 9 bits. So in total the size of this integer is 4 byte, so the size of this one would be 4 byte. And 9 plus 6, 15, so out of 32 we will be using only 15 bits. But what if you want that this first 6 bit should go in first block of the memory, I mean first 4 bytes, and this another 9 bits should come in another 4 bytes. So this is the way of doing that. If we will check this compiled, see it is 4 and 8. So this first one is 4, because as I said the integer size is 4 bytes, so inside 4 first 6 will be occupied, I mean 6 bits will be occupied, then 9 bits will be occupied in the same 4 byte. Okay, but in this case it is different. It will create 4 byte for this data type and use only 6 bits in that. And as we are saying that we are putting this unnamed bit field just to tell to the compiler that I want this 9 bit from another 4 bytes. So 4 plus 4, 8. Okay, so this is also possible in bit field. You can customize like this. Okay, so this was your first point, that force alignment is possible using unnamed bit field, and this is how you use that. So the second point says that taking pointers to bit field members are not allowed as they are not starting at the byte boundary. We cannot take the address of bit field member. This A is of bit field member. We are using this colon and 5, so it has become bit field member. We cannot take the address of this A and B, but we can take the address of C. So that's how what I'm trying to tell you here. C, this will error because C is not bit field member. Okay, and the reason is A and B are not necessarily starting at the byte boundary. And what is byte boundary? As we are taking this A and B, it might be coming, as I said, from half would be this C here, and this A and B, either A might be at this point and B will be at this point, and A is of 5 bit and B is of 5 bit. So 1 byte is 8 bits. We all know that. So if you are aware of this, that our RAM is addressable, and we can address 1 byte inside the RAM. Okay, so 1 byte means total 8 bits. So minimum byte you can address is 1 byte. But this B or A, neither of these are 1 byte. So taking the address of that doesn't make any sense. So this was your second point. Let's comment this and let's go to the third point. Now this third point is assigning an out of range value to a bit field member is implementation defined. So as you can see here, you're having this A with 2 bits. So either you can set 0 or 1. So 2 bits means there is only 4 possibilities. Okay, 2 to the power 2, so means 4. So only 4 numbers can come in A, B and C, but if you are putting more than that, then it is a problem. And it is not a problem actually, it is implementation defined. So whatever the compiler you are using, the compiler vendor will tell you what will happen when you will do something like this. So in the specification, you will get all the details. Okay, so doing this is not good practice, and there is no need of doing this, because before going for any bit field decision, you should always confirm that this is not going to take more than 2 or something, whatever value you are choosing, but A is not going to take more than that. That's why you are putting that. So if you are confused, don't use bit field, because in future you may have to change your full code. So we are done with this third point. So third point was we cannot initialize more than what A can handle. Okay, so that was the third point. Let's comment out and go for the fourth point. Fourth point says that you cannot have static bit fields, because we are watching this video in C++ section, so we have to cover C++ style. So in that case, we can have static data members inside structure and classes in C++, but if this is a bit field data member, you cannot use static with that. So this was the fourth point. Now let's look at the fifth point, and that is most probably the last point. And the fifth point is you cannot have the array of bit fields. Okay, so these points are very easy to remember. I got it from somewhere in the internet, and I like to explain almost everything about the topic, so I have included these points here. Otherwise our video was completed long back. But these points are really very interesting when it comes to the interview questions or writing a good exam. Okay, so this fifth point is you cannot have this array. And yeah, if you will write some extra points in your exam, you will get a good marks, and that's a good thing. So fifth point is this much only, you cannot use it as array. Okay, so let's look at the summary of this. So the summary of this video is bit fields are from C language and they are not different in C++. So this is first point, which is not a very big point but still good to remember. And second point is it is used to reduce the size of the classes or structure if we can. If we can means if we are in situation like I gave you the example here of this date data structure. So we have that option, like you can reduce the size of your data member because it is not going to exceed some limit. But in case if you don't have, don't use bit fields. So third point is this feature is great in embedded system because there is a scarcity of memory. Yes, it is really very important when you go for embedded systems, and if you are planning to make your career in embedded system, you should be very good in all these things. When there is a topic about memory optimization and all that, you should be very good at that, because as an embedded developer you should be writing a very good code in terms of memory optimization and all. And structural padding, I don't know why did I write this. Oh yeah, maybe this topic is very much important in order to understand your bit field. So before you should understand this one, and as I said, I'll be giving you the link in the description field. You can go ahead and watch there. And the fifth point is only integral types like boolean character, signed character, unsigned character and all these things are allowed to be bit fields. Okay, so we will go here, and as you can see here I'm using unsigned integer. Okay, here you can use only integral types, and those types are this one. You cannot use float or double or something here. Okay, it need to be an integral type, and these are the types. So I think we are done now. Thanks for watching. And if you like the video, don't forget to hit the like button and please comment how do you feel about the video, because it will help me a lot to understand my audience, what they like, what they don't like. And you can write comments, very big, very small, doesn't matter. You can just say thank you, or you can just say I didn't like this or something like that. It's okay. I'll try to improve there, okay? So I'll see you in the next video. Bye bye. And yeah, make sure you subscribe to my channel so that you will get the notification for upcoming videos like this. Bye bye.